Welcome to the second episode of the making of the Antikythera mechanism.
Last time, we discovered the mechanism together. In this episode, we will dig deeper and look at the context in which the mechanism was built, then study the planets, which may also have been represented on the front dial. Lastly, we will learn about a very important tool for engineers, reverse engineering.
It is not unlikely that the ancient Greek technology was more advanced than we thought. Many great discoveries in other subjects like mathematics or even politics were made during that period. Let's take a look at the scientific situation in which the Antikythera mechanism was created.
The most well-known scientists, such as Plato, Aristotle, Socrates, Archimedes, and women like Hypatia, were also philosophers, demonstrating the importance logical thinking had in their different discoveries. Another significant aspect of their lives was teaching. This shows that communicating knowledge has been an essential part of science ever since ancient Greece. The hypothesis that the Antikythera mechanism was used for educational purposes has been put forward by some historians of science.
One more possibility, although it is a bit less popular among historians of science, is that the device was used for navigating. Another famous ancient Greek, Thales, discovered 500 years before the Antikythera mechanism was built, how stars could be used by sailors to know their positions.
Other great discoveries, specifically in the field of astronomy, include Ptolemy's understanding that the Earth is spherical, not flat as previously thought.
Sorry, flat earthers, you're almost 2,000 years behind science.
Ptolemy also conceived the idea of epicycles. From the geocentric perspective, with the Earth at the center of the universe, planets' orbits are circular with a kind of back and forth motion.
Later, this weird shape of motion was understood to mean that planets revolve around the Sun.
Actually, Aristarchus proposed a heliocentric model around 300 BC, 400 years before the Ptolemaic system was devised. However, he couldn't prove his claims, and his model was forgotten. But since then, we were able to confirm his idea that the stars are other suns and it must be the planets that revolve around stars.
In fact, we have now discovered over 4,000 exoplanets, planets orbiting other stars.
We will remain more local in our astronomy section. We will consider our solar system's planets.
In a few episodes' time, we will learn about the significance of astrology to ancient Greek culture, for which planets play an important role. Here we will focus on some astrophysical concepts.
The 5 planets known before telescopes were used are Mercury, Venus, Mars, Jupiter, and Saturn. This is because the apparent magnitude of Uranus and Neptune are just at the limit of what can be seen with the naked eye. Apparent magnitude measures the brightness of a celestial object as seen by an observer on Earth and is an inverted scale. The larger the magnitude, the less bright the object you're looking at.
The Sun seems so bright to us that its apparent magnitude is -27.
To see a celestial object, its apparent magnitude has to be less than about 6 for a trained eye. Uranus is just under that limit at 5.73. But since it's so distant and has such a slow movement, it was considered a star until the 18th century. Neptune is not visible at all with the naked eye, as it's even further away. Its apparent magnitude is only 8.
As just touched upon when talking about Uranus, it's the motion of the planets that makes them differentiable from stars.
As we have seen when talking about the ecliptic last time, stars form a sort of background on which the objects closest to us, like the Sun, appear to move. When they are visible, Mercury, Venus, Mars, Jupiter, and Saturn will change their positions relative to that background each night. It's by tracking these positions that the planets can be distinguished from stars.
There are so many interesting facts about the planets of our solar system.
Did you know that although Mercury is closest to the Sun, the hottest planet is our closest neighbor, Venus? Its surface temperature is on average 464 degrees Celsius, when on Mercury it's only 430 during the day. This is due to the fact that Mercury has no atmosphere and cools down to temperatures as low as minus 180 degrees Celsius. But Venus's atmosphere mainly contains CO2, making it a giant greenhouse. We wouldn't want our planet to end up like that.
Some people think that if we nuke it, Mars could host human life. We could all be climate refugees on the no longer red planet.
For scientists, Mars is more than that. You've probably heard of at least one of these: Viking, Opportunity, Spirit, Curiosity, or the upcoming Rosalind Franklin. These are all names of some of the rovers that explore the Martian surface or will soon, notably in search of life. Mars could have been, and still be in some places, habitable.
We are not talking about little green men here. What's more likely is that there are microorganisms, or traces of them.
Astrobiology is the study of life elsewhere in the universe, and another research target for this is Jupiter, more precisely, the moons of Jupiter.
Jupiter's moons, and also its fascinating red spot, as well as Saturn's beautiful rings, were first observed in the 17th century, so the ancient Greek did not study that, and certainly did not incorporate this information into the mechanism.
Still, it's very likely that they thought about the possibility of life elsewhere in the universe. In fact, it's been established that Plutarch was speculating on lunar life just a few decades after the Antikythera mechanism was built.
But how do we know how the surviving fragments of gears were assembled? Or what the mechanism looked like? That's our next question.
Engineers only had the fragments from the wreck to analyze and to understand how the original mechanism worked. 7 larger fragments with gears remain, and out of the 75 others, 15 have been used for studies of their inscriptions, which helped researchers comprehend the mechanism better. The gears were first analyzed with X-ray in 1971 by someone we already encountered in the first episode, Derek de Solle Price.
As technologies advanced, it became possible to conduct polynomial texture mapping, or PTM for short, allowing researchers to analyze the surface of the fragments in enhanced detail. From those two methods, scientists were able to devise theories of what the gear trains for the moon, calendar, and eclipse prediction dials, and how these were arranged.
To fill the gaps, they used the known gear ratios and astronomical values, as well as the locations of the pointers.
The only undiscovered part of the mechanism is the lost epicyclic gearing. This is the one that possibly included the solar mechanism and the planetary mechanisms.
However, as we have seen in the astronomy section, ancient Greeks had a good knowledge of these astronomical processes, and it's not unlikely that they were modeled on the mechanism.
For our replica, we have been using Fritz and Jones' model of this lost epicyclic gearing, as it considers the limitation of the gear-making process at the time, thus being the most plausible model. In particular, it considers the tolerance, that is, an error value that a design can admit to still function if the piece is bigger or smaller by that value.
This time, we have advanced our understanding of the ancient Greek civilization and their scientific practices. Then we finished the study of the astronomical features on the front dial and looked at how theoretical models for the gearing system were devised. In the next episode, we will look at ancient science more broadly by focusing on calendars from different civilizations. This will lead us on to think about eclipses. Last but not least, you will have a crash course in computer-aided design, or CAD.